Hi there, this is Mrs. Tellas. We are going to go through section 5.2, which is solving systems. And instead of by graphing, we're going to solve today by substitution. So this first problem is what we did in the first section, solve by graphing, solving systems by graphing. So let's go through this one real quick. So if you didn't get to see the notes there, maybe you can pick it up here. So I need an m and a b for this equation. So my slope is 5 over 1, and my b is plus 0. So if I graph that, that'd be a 0, up 5, right 1, up 5, right 1. I could also go down 5, left 1, and then I'm going to try to draw a straight line. Okay, and then this one over here is not in the correct form. It's in standard form, and I need it in slope-intercept form. So I can pull the slope and the b out. So I'm going to move things around so y is in front by itself. So I'm going to subtract 2x on both sides. And then I'm going to divide by -1 for each. So that's y equals 2x minus 3. So my slope here is 2 over 1, and my b is 3, negative. So let's see, if I graph that, that'd be down 3, and then up 2, right 1, up 2, right 1. Notice I'm getting further away, so I'm going to go the other way, down 2, left 1, and that's where my answer is. My answer is where the two lines intersect, and they intersect right, let's show us with a flower right there. They intersected that point. So the solution then is -1, 1, 2, 3, 4, 5. So -1, 5. -1, -5. Okay, so, and I could draw my line in as well. I don't need to just leave it dots. Okay, so here are the directions for solving by substitution if you want to press pause and write them down. Some of you really like to write directions down, so if that's what you want to do, go ahead. And I'm going to go ahead and move on to keep the video short, but you pressed pause, so no big deal. All right, so this is the exact same equation. We already know that the answer is -1, -5, but this time we're going to solve by substitution. So what we're looking for is we're looking for x or y alone. Well, I see it right here. Y is 5x. So in the other equation where I see the y, I'm going to take the 5x and I'm going to put it in there for y. So I'm replacing the y with the 5x. So as I write that, it'll be 2x minus 5x equals 3. And then I'm just going to solve for x. So that's -3x equals 3, and x is -1. Well, so my answer is -1 something. Well, I already knew it was -1, -5, right? Because we graphed it a second ago. So now to get the y, I take the -1 and I stick it back in here to the easy one where it's solved. So y equals 5 times -1, so y is -5. So it's just another way of solving the system. And for me, it's a preferred way. Okay, I could leave graphing in the dust, no problem. Graphing's definitely not my favorite. All right, number 2, same thing. I'm looking for where x is already solved or y, and I notice that x is solved right here. So I'm going to take this part right here, the rest of this, and I'm going to plug it in the other equation for x. So in for this x, I'm going to put 4y plus 5, and then equals 3y minus 2. And this is where my solving skills come in. So I'm subtracting 3y from both sides. So y plus 5 is -2, and I'm subtracting 5 from both sides. So y is -7. And so now I take that -7 and I plug it back into the original equation that I plugged. So x equals 4 times -7 plus 5. So x equals -28 plus 5, so x is -23. Okay, so I have half of the solution. I need the y now. Oh, I already have the y. So -7 is my answer. So my x was -23, and my y is -7. And remember what this represents. It represents where these two lines cross on a graph. Okay, that's what it represents, their intersection point. So notice this one doesn't have one that's already solved. So we want to go ahead and get this guy right here. He would be that term would be the easiest one to solve for because he has a coefficient of 1, or he's alone. So I'm going to go ahead and move this 4x to the other side by subtracting. and y equals negative 4x plus 11. So now I'm solved. I've got y equals all of this. So in the other equation, I'm going to put this green part in for y. So 8x plus 2 times the quantity, negative 4x plus 11 equals 13. Now I'm going to use my solving skills and distribute. Combine like terms. Well, those two cancel. So this says 22 equals 13. Well, that's not true. That's false. So the answer is no solution. And since the answer is no solution, that means that these lines are parallel or have the same slope. Okay. All right. Number 4. Okay, I notice that x is solved right here. Okay, so I'm going to take all of this and put it into the other equation for x right there. So 2 times 1/2 x, 1/2 y, let's change that, plus 3, and then minus y equals 6. So again, I'm distributing, so that'll be y plus 6 minus y equals 6. Well, again, these y's are going to cancel. They don't always cancel, but they did in these last two. And I have 6 equals 6. Well, that's true. 6 does equal 6. So that means this equation is infinitely many solutions. Or some of you like to say all solutions. Same thing. Okay, and what that means is these two lines are actually the same line. If I were to graph it, they'd have the same slope and the same b. So they're the same exact line, just in different forms. So they share all the points, which is why it's infinitely many. All right, you go ahead and try one, please. If you haven't, please press pause and try 5 and see if you can get it by yourself. Remember, you're looking for the point where they intersect. You probably want to go after this x right here because it's the only term that has a coefficient of 1. So you want to move the 3y over and then try to plug it into the other equation for x. Give it a try, please. All right, so if I solve this, I want to move this minus 3y onto the other side so that I can isolate the x. So that's x equals 3y plus 1. Okay, see how the x is solved? So I'm going to take this whole thing and I'm going to plug it in for the x right there. So 3 times 3y plus 1 minus 5y equals 11. So if I distribute, that's 9y plus 3 minus 5y equals 11. So 4y plus 3 equals 11. So if I subtract here, I get 4y equals 8, and I'm dividing, and y is 2. So again, I have half the solution. So now I use y equals 2, and I take it, and I can put it into any of them, but the easiest one to put it into is the one that's solved already for one of the letters. So I take the 2 and I put it right here. So x equals 3 times 2 plus 1, so x is 7. So my beginning is 7, 2. 7, 2 is the point where those two lines cross. It's the solution. All right, I hope you got that. If you didn't, I hope you figured out why you didn't, if you just made an arithmetic error or something like that. All right, so here's a story problem. It says a snack bar sells 2 sizes of snack packs. The large snack pack is $5 and the small snack pack is $3. In one day, the snack bar sold 60 snack packs for a total of $220. How many small snack packs did the snack bar sell? All right, so we're going to set up 2 equations here. One about cost and then one about the number of snack packs sold. So let's make, I hate S for a variable. Let's do X is the small snack packs and L is the large, L for large. All right, we want one about cost. So we're talking about how much these things cost. So the large is 5, so 5L, and the small is 3, so 3X. And they told that the money is total is 220. So that's my first equation. So I've got one about cost, and then the other one's about quantity, how many we sold. So we sold some large, we don't know how many, and we sold some small, and it totaled 60 snack packs. Okay, so now I can use substitution to solve. So it doesn't really matter which one we solve for because they both have a coefficient of 1. I'm going to go ahead and just solve for L. So I'm subtracting X. So L equals 60 minus X. Okay, so now it's solved for L, and I can take this part and plug it in for L into the cost equation. So I'm going to put what I highlighted here in yellow. I'm going to put that in for L right there. So 5 times 60 minus x plus 3x equals 220. So now I'm going to use the distributive property. So 300 minus 5x plus 3x equals 220. And I'm subtracting 300. That's negative 80. And when I combine those two, that's negative 2x. And then I divide negative 2. So there were 40 small snack packs sold. And then to figure out the other one, I just take the 40 and put it in here into the solved one. So for the large one, it's 60 minus 40. So the large one sold 20. So the question says, how many small snack packs? Well, I already had that. It's 40. Okay, so that's how I do that. I've got one set up about cost. See how there's 3 different numbers that have money. Okay, so that was a giveaway that there was one about money. And then the only other number is about the quantity. So I knew it was some large and some small, so I just did x plus y, or x plus L in this case, equals 60. Okay, so you have a big ideas assignment over substitution. Now we showed a ton of work for every single one of those problems, so there should be work to be shown. So once you get your work done, you check for correctness and big ideas like normal. And once you get your work done, submit that on Canvas. Submit a picture of your work on Canvas, please. All right, have a good day.